Topics covered in linear programming. Welcome to our study of linear programming. To begin, let's define what this concept actually entails. Linear programming, often referred to as LP, is a powerful mathematical modeling technique used to determine the best possible outcome in a given scenario. This typically involves either maximizing profits or minimizing costs. At its core, the process involves optimizing a linear objective function while adhering to a set of linear constraints, which are simply the limitations or requirements expressed as linear inequalities or equations. Throughout this chapter, we will work toward four primary learning objectives. First, we will establish a foundation by learning the essential terminology, including decision variables, constraints, and the feasible region. Second, you will learn the skill of mathematical formulation, which is the ability to translate complex, real-world word problems into structured mathematical models. Third, we will master the graphical method, where we plot linear inequalities on a coordinate plane to visually identify the optimal solution. Finally, we will focus on optimization, specifically learning how to analyze the vertices of a feasible region to find the maximum or minimum value of our objective function. Once we have mastered these mathematical foundations, we will move on to our next slide, where we will explore the fascinating real-world applications of these techniques in fields such as business, logistics, and even nutrition. Real-world applications of linear programming. Now that we have established the mathematical foundations and the core terminology of linear programming, let's explore why this topic is so vital in the real world. Linear programming is much more than just a classroom exercise. It is a fundamental tool used across various professional industries to make smarter, more efficient decisions. In the fields of business and economics, for instance, companies use these models to optimize their product mix, ensuring they maximize revenue while staying within the limits of their available labor and raw materials. Moving to logistics and supply chain management, transportation firms apply these techniques to identify the most cost-effective routes, which helps in reducing both fuel consumption and delivery time. Even in the realm of diet and nutrition, specialists use linear programming to design meal plans that satisfy all essential nutritional requirements at the lowest possible cost. Finally, in resource management, engineers and government agencies rely on these models to manage energy distribution and the allocation of our planet's scarce natural resources sustainably. By mastering these concepts, you are acquiring a critical analytical skill that enables you to make optimal, data-driven decisions in any situation where resources are limited.